Good morning, geometry students. Today we continue on with our trig identities or our trig definitions, the sine, cosine, and tangent. We primarily are going to be doing something called angle of depression and elevation. These top three problems here are an opener. I think in the last video I had mentioned that you don't really do trig with our 30, 60, 90, and 45, 45, 90 families because we don't need to, because we already know all the sides and the angles, but that's a little bit misleading. When you get into Algebra 2 and you get into the next big trig unit, you'll see that doing SOHCAHTOA, sine, cosine, and tangent with these families is actually a pretty big part of trig. What we don't do with these families typically is just read these answers right off the chart, off the trig table. And we don't always just punch them into our calculator. So what we are going to do with these is write our answers in simplified radical form. All right, so we are going to be using our SOHCAHTOA. Before we can do that, we need to find the missing sides, which we can do based on our knowledge of the families, right? So when we have the short leg on the 30, 60, 90, hypotenuse is double, okay? And the long leg is whatever the short leg is times the square root of 3. Okay, and then let's see, I'm going to write it up here. Here's our SOHCAHTOA. All right, so we know that the sine of the 60-degree angle is asking us to write a ratio of the opposite side over the hypotenuse. All right, so we go 60-degree angle. Opposite the 60-degree angle is the 3 root 3 side. Hypotenuse is 6. All right, and these two will reduce. So the sine of 60 degrees is root 3 over 2. And we're just going to leave it like that. If we plug this into our calculator and looked it up on the chart, right, we should see a match, that this decimal approximation is going to match up with the sine of 60 degrees, but we're not really going there. Cosine of 60 degrees, right? Cosine is adjacent over hypotenuse, so that is 3 over 6. So the adjacent side to the 60-degree angle is the leg that touches the angle. And in trig, hypotenuse is always referred to as the hypotenuse. So that's just a half. And then the tangent of 60 is opposite, 3 root 3 over adjacent. Okay. Next one. Let's see. So the hypotenuse is 12, which tells us that the short leg is half of that, 6. And remember, this comes from the equilateral triangle family, right? That's how I always remember. It's the hypotenuse and the short leg that are the double halvesies of each other. The long leg is the one with the square root on it. Okay, square root 3 for this family. All right, so sine of 30 degrees is opposite over hypotenuse, so 6 over 12, half. Cosine of 30 degrees is adjacent over hypotenuse, so that's 6 root 3 over 12. That reduces to root 3 over 2. Tangent of 30 is opposite over adjacent. So 6 over 6 root 3. All right, so this one, when you reduce it, it reduces down to 1 over root 3. So we're not supposed to keep it like this, correct? So we have to do some extra steps on this one. Root 3, root 3. So the numerator becomes square root of 3 over regular 3. All right. And then onward to the 45, 45, 90-degree family. So this is the one that comes from the square. So I know that the two legs are going to be equal. So 7 and 7. And it's the hypotenuse on this family that takes on the square root side, which is square root of 2. All right, so the sine of 45 degrees. All right, so 45 degrees sine is going to be 7 opposite over hypotenuse. 7 over 7 root 2. Well, the 7's reduce, but then you're left with 1 over root 2. Can't leave a root 2 in the denominator, so we're going to do some work here. We're going to multiply by root 2 here and root 2 up here. Right? That's called rationalizing the denominator. So numerator just becomes square root of 2. Denominator becomes 2. It looks funny, I know, but that's it. That's the sine of 45 degrees. Cosine of 45 degrees, well, look at that. Adjacent is also a 7, and hypotenuse is 7 root 2. So adjacent over hypotenuse. Right, same as the sine of 45. So we know what that's going to end up like. I'm not going to show it again. And tangent of 45 is opposite, which is 7, over adjacent, which is also 7. That's an easy one. Actually, some of these are easy, super easy to just check in your calculator, right? Hit tangent of 45, you should get 1 back. Sine of 30, you should get 0.5, right? And cosine of 60, same deal. You can check the other ones almost as easily, but all right. Let's move on to angle of elevation and depression. Okay, so in this space below here, we're going to make a little diagram. So if you guys could put a bird up in this corner area here. We'll take it as a snapshot in time because we don't want that bird to move anywhere. Oh, darn it. Okay, and then let's make the ground pretty level, okay? And say over here we're going to put like a boulder or a rock or something. Okay. So when we talk about angles of elevation and depression, those are angles that are created between two objects. One is above the other, and the other is below the other. So first line we're going to draw on here is a line that connects the two objects, and this is called the line of sight. Okay, so the angle of elevation is the angle formed by a horizontal line, so that's going to be our ground, and a point, and a line of sight to a point above the line. So if the rock was looking, right, it would look up to that bird, and this angle right here is the angle of elevation. Angle of elevation. Okay, most people are cool with the angle of elevation. It's the angle of the depression that a lot of people goof up. So when you have to identify an angle of elevation, first thing you do is not try to draw an angle on here. You draw an imaginary horizontal line, or an imaginary line that is parallel to the ground. Okay, so this line right here is parallel to the ground. Oh, do you remember how to indicate parallel lines on a chart? You put another extra little pair of arrows on the lines. All right, and so the angle of depression is the angle formed by a horizontal line, that's that imaginary one we just drew, and a line of sight to a point below the line. So that's this angle right here. I'm going to put a 2 in there, and that angle is the angle of depression. All right, so one observation, if you remember back from chapter 3, is that we had some information about angles and how they were related to parallel lines. So if I trace over this pair of angles here, and this transversal, the line of sight is the transversal, you should see a lovely Z shape right here. That means that this pair of angles, the angle of depression and the angle of elevation, are a pair of alternate interior angles. And when you have parallel lines, those alternate interior angles are congruent to each other. All right, so kind of an important result of these two angles is that angle 1 is congruent to angle 2, right? Angle of elevation and angle of depression are congruent because they are alternate interior angles formed by parallel lines. Okay, these two examples at the bottom of the page are just to kind of practice identifying and drawing the correct angles. So, complete the drawing. Angle of depression from the butterfly to the flower is 20 degrees. Okay, so we have a butterfly and a flower. We're going to draw in our line of sight. We're going to first, before we do anything about angles of depression, we are going to make this imaginary horizontal line here. Let's make the ground here. So angle of depression is 20 degrees. That's that angle right there. And that's really all you had to do for this problem. All right, these lines are parallel. Okay, complete the drawing. You are on the ground looking at a hot air balloon. Is this an angle of elevation or an angle of depression? All right, so let's make a ground. And you are down here looking. All right, so if you look up to the hot air balloon, that's the line of sight. From you looking up, this would be an angle of elevation, right? And I know there's always kind of some discrepancy about when it's a person and their eyes are like 5 or 6 feet above the ground. Where do you put that angle? And I think we're being just a little, not sloppy. We're just not really taking into account. We're just going to say that these objects are so far away that this difference is going to be negligible. So the eyes would be close enough to the ground that we're going to just call this whole angle right here angle of elevation. So this is an angle of elevation. Okay, on the back, some examples. A lifeguard is sitting in his chair looking at the swimmers. All right, so his line of sight is from here to the swimmers. His angle of depression is 33 degrees to the swimmers. What is the angle of elevation from the swimmers to the lifeguard? All right, so anytime you do an angle of depression, right, you make that imaginary line 33 degrees from him to the swimmers. Pretend like the water is the ground, right? So that means this angle of elevation from the swimmers up to the lifeguard is also 33 degrees. All right, that's all you needed to answer for that guy. Okay, next problem. A pilot is looking at an airport from her plane. The angle of depression is 29 degrees. If the plane is at an altitude of 10,000 feet, how far is it from the airport? Complete the drawing and solve it. Okay, so let's make a ground, I guess. All right, and then we'll just put the airport over here. So first thing we're going to do is our line of sight. And the question gives us an angle of depression. All right, so first thing we do when we draw an angle of depression is the imaginary horizontal line that goes parallel to the ground, because this is the angle of depression, 29 degrees. Okay, if the plane is at an altitude of 10,000 feet, so an altitude is a distance directly below this airplane, perpendicular to the ground. So that is how we get a right triangle out of this, right? 10,000 feet. So the next question is, how far is it from the airport? So sometimes there's confusion about which dimension are they asking. I believe with airplanes, they are asking air distance. So how far is it? I'm going to just say air distance. Sometimes it gets interpreted as ground distance, this dimension right here, but we're just going to say this plane is going to fly directly to that airport right there. So I want that distance right there. Okay, So there's a couple ways you could do this. Because I already have this triangle kind of lined out here, I'm going to use this triangle right here, but you could draw another line here and then use this triangle here. The problem is this triangle doesn't have an angle on it, but I know that this angle of depression would be the same as this angle of elevation. So I'm going to put my 29 degrees right there. And now I'm going to, from this angle right here, this side is opposite. And this side I'm trying to find is a hypotenuse. So if I have an opposite and a hypotenuse, and I do my SOHCAHTOA, what I have is a sine relationship, right? So I'm going to say sine of 29 degrees equals 10,000 over x. Okay, so I'm going to put the sine of 29 degrees over 1, and I'm going to cross multiply. So I'll get x times the sine of 29 equals 10,000. And you can replace that sine of 29 with the decimal number. I'm going to go ahead and just keep it as sine of 29. Sine of 29, I didn't space out my work very well. Okay, so now we're going to go ahead and just punch in the calculator, right? 10,000 divided by sine of 29. And I get 20,626.6 feet. It doesn't say how to round it. I mean, a number that big, I just kind of want to round it to the nearest foot, but I'll go ahead and take it to the tenths because that's kind of the general rule. If it doesn't say how to round it, right, you go to the nearest tenth. So 20,626.6 actually be 0.7 because that 5 would round the 6 up to a 7, 0.7. And our units were feet. It didn't really ask us to convert it to miles or anything. We'll just go ahead and leave it like this. There's 5,286 feet in a mile if you wanted to divide it out and figure out how many miles, but okay, so it's very important that you generate a picture with this. A dog is looking at a squirrel at the top of a tree. The distance between the two animals is 55 feet, and the angle of elevation is 64 feet. How high is the squirrel, and how far is the dog from the base of the tree? So hopefully we can kind of figure out what dimension is what. All right, so here's the tree, right? And here's the ground. So we have a little squirrel up in the top of the tree. Let's see. Okay. And then on the ground, we have our little dog here. And the distance between the two animals is 55 feet. So based on what we're supposed to find, I do believe that that 55 feet is the line of sight. So let's draw in the line of sight. I'm going to leave the 55 off for a minute because sometimes I've got to read through it and figure out what goes where. It says the angle of elevation is 64 degrees. So we know that that's that angle right there from the lower thing looking up to the higher thing. So it's asking how high is the squirrel, which would be like how high is this tree? I'll make that my X. And how far is the dog from the base of the tree? So I'm going to make that, so from here to here, my Y. All right, so I do believe that the fact that these two creatures are 55 feet apart means that that is my line of sight dimension. Okay, so we just have to find each of these. I'm going to go ahead and find the X first. So when I look at this angle right here, right? X is the opposite side, and the hypotenuse, 55 is the hypotenuse. So opposite and hypotenuse are a sine relationship. All right, so I'm going to write sine of 64 degrees equals X over 55, right? So SOHCAHTOA. Okay, multiply both sides by 55. So this is pretty much calculator ready. 55 times the sine of 64. Okay, 55 sine 64 equals 49.4. It doesn't say how to round it, so we'll go to 1 decimal place. And since that 55 was in feet, this dimension will be in feet as well. All right, now for y, I mean, you could, now that you know what x is, you could Pythagorean theorem. To get y, use Pythagorean theorem. I'm just going to use trig simply because that's the unit that we're in, but 64 degrees, y, and 55, these three form a cosine relationship. This angle, or this side, is adjacent, and the 55 is the hypotenuse. So cosine of 64 equals y over 55. Okay. $24.1. Okay, and last question. So we got to generate our picture. Let's see. A lamp post is 11 feet tall. If the angle of elevation from the tip of the shadow, the tip of the lamppost's shadow to the top of the lamppost is 49 degrees, how long is the lamppost shadow? Okay, so sometimes these questions you have to, I don't know, kind of put some things together. Here's a lamppost. I mean, if the lamppost was the source of the light, I don't totally know how it would make a shadow with its own post per se. So I guess I'm kind of picturing that perhaps there's a sun, like it's a lamppost during the day. We'll say there's sunlight outside, and it is coming down and shining behind this lamppost, and the lamppost shadow is on the ground. So just keep this in mind. Sometimes people goof this up, but shadows are always on the ground, okay? So when they talk about a shadow, it's not that, imaginary line of sight that you would draw in there. It's the shadow is what's on the ground. Let's see. So the lamppost is 11 feet. The angle of elevation from the tip of the shadow. Okay, so remember, angle of elevation comes from the ground or the lower thing up. So this is the tip of the shadow up to the top of the light post. So sometimes people put that dimension somewhere, up at the top here. So, line of sight, I know these things don't have eyes, but you need to sketch in this third dimension, third side of your triangle, okay? That would be your right angle. Angle of elevation has to be here. Sometimes people kind of put it up there by mistake. Really, there's nothing that lets you put anything directly there. Sometimes, there are ways you can get what that angle is, but we haven't really been using it. We're trying to go strictly from angle of elevation or angle of depression. Okay, how long is the lamppost shadow? So that's what we're trying to find out. Okay, so it looks like with this angle, this is opposite and this is adjacent. So this is a tangent ratio. Tangent of 49 degrees equals opposite over adjacent. Okay, our unknown is a denominator this time, so this is where I like to cross multiply. So x times tan 49 equals 11. Divide both sides by that number, tan 49. You can get it off your chart if you want to. All right, 11 divided by the tangent of 49. That is calculator ready. That's kind of why I like doing it this way. Also, if you are using your chart, and I'm showing the notes here with the calculator, sometimes there is discrepancies in the decimal places, and that's okay, because the calculator carries out more than 4 decimal places. You just, when you use the chart, you have to do those 4 decimal places. You can't cut those ones short. Okay, so it looks like 9 point, and that 5 is going to round up to a 6 because of that 6 right there. So the shadow is 9.6 feet. All right, thank you.